Link is stuck in yet another puzzle room, this time in Stone Tower. He needs to use his mirror shield to reflect light from a sun face oriented 45 degrees from the normal and 10 meters away from him into a diamond prism that is also 10 meters away, which will then refract the light and strike a sunblock to clear his path into the next room. What is the angle of refraction when the light leaves the prism and strikes the sunblock? How far will the light travel from the prism to the sunblock, given that the block is 6 meters away from the prism? Here we have a visual representation of our setup as described in the problem, and here a more crude representation. The light wave is coming from a 45-degree angle to the normal, and it comes both into and out of the mirror shield at 45 degrees as well, following the angle in equals angle out rule for reflection. Thus, the light comes into the prism at 45 degrees as well. Another way to look at this situation is by drawing a right triangle. If we draw it between the two paths of light to and from the mirror shield, we see that the angles in and out are 45. Because one corner of the triangle ends up being 45 as well due to the angle rules, the other corner of the right triangle must also be 45, thus making a nice isosceles triangle, which is supported by the fact that the lengths of the paths are both 10 meters. Moving on to solving the problem, we have this right triangle for which we need to find theta, the smallest angle, and the hypotenuse. Let's solve for theta first. We'll use Snell's law, which relates the angles of incidence and refraction between two media through which the light passes. On the left side, we have the index of refraction of air, which is just 1, times the sine of the angle of incidence into the prism, which is 45 degrees. So the whole left side is just going to end up being the sine of 45. On the right side, we have the index of refraction of diamond, 2.5, times the sine of the unknown angle theta 2. To isolate theta 2, we divide both sides by 2.5, and we calculate that theta 2, the angle of refraction, is 16.43 degrees. Now, to solve for d, the distance that the light travels from the prism to the block, we use Ka from SOHCAHTOA and say that the cosine of 16.43 equals 6, the adjacent, divided by d, the hypotenuse. We isolate d by rearranging the equation to look like this, and we do the math to find that d equals 6.255 meters.